Hi, everybody, and welcome back to another cringe-worthy episode of Miss B's Screencastify tutorials. My thought with this Properties of Water lab that I would allow you to mildly struggle through using Google Sheets for graphing, but I forgot that we had a much longer break and our brains have been shut off from school for a lot longer than many of you have had in terms of visiting Google Sheets and making graphs. So this is going to be more of a training wheels type of tutorial. I'm going to walk you through what your specific data table should look like for the Properties of Water lab. I'm going to use some practice data. This is not going to be data that you will collect from the YouTube video of myself doing the procedure, but it's going to give you a guide as to how to calculate the mean or the averages of your trial data and how to calculate the standard deviation and standard error from that specific mean. Okay, so here is a part of the video where you could pause it. You could open up a Google Sheet and you want to make a data table that looks just like this one. Okay, so you want to pause the data, make one that looks just like this one, and then while you're at it, you can go ahead and fill in your trial number 1, 2, 3, 4, 5 for all of your additive types, your distilled water, water and soap, water and sugar, and oil. So give it a pause, go ahead and fill those values in. Welcome back. I hope that wasn't too horrible for you. Again, these values are going to be different than yours because they are made up. I ballparked these values just based off of our data, and what I remembered might be the numbers for each of the trials. So first thing you want to calculate once you have your trial 1 through 5 in for your additive types is the mean or the average for those samples, because in order to calculate how far your data values deviate or are dispersed from that average, aka the standard deviation, you're going to need the mean. And then in order to calculate the standard error of the mean, which is something that measures how good your sample mean is of a projected population mean, you're going to need, again, the mean. So let's type this one in. This is going to be one of the more easy Google Sheets equations that you are going to type in. So we're going to go equals. Sometimes Google Sheets is predictive and it knows exactly what you want to do. It sees mean and it knows that mean and average are synonyms. There's your value, and it also knows that these are the values that you want to use, trial 1 through 5, to calculate your mean. So go ahead. If it doesn't highlight for you just like it did for me, you're going to drag your mouse cursor across these, highlighting those cells, and then you're going to press enter. It's going to give you an average. Make sure that average looks in the ballpark. If it said 72, you did something wrong. So once you have that value, you're then going to hover over till you have this plus sign, and you're going to drag, drag that formula, not the value, the formula down to the rest of the cells. I promise it's going to work. Okay, so there it goes. I just eyeball my numbers. They look at like an appropriate mean or average for my trials for each additive type. So now we're going to come over here to the standard deviation. So again, standard deviation, you're going to watch a few videos that give you a overall description of this. And it's important to biology because you want to know how much your mean or of your sample is deviating from the actual mean of a population. How much spread do you have? Do you have a good sample size where they're close to the average, or is your sample kind of all over the map? And what does that say about your specific sample of data that you collected? Okay, you can make a lot of interpretations from that. So to calculate it, we're going to type in another formula. Okay, so we want to go equals. And that specific formula with your little caps key on, you're going to type in STDEV, a period, and we want to go S. You might see P pop up, but this is not a full population. This is a sample, so we're going to click on this one, S. Now, this is where I'm going to drag my cursor over my sample size. That's trial 1 through trial 5. We're going to close our cursors, and we're going to press enter. And that's our standard deviation of the sample. Now, quickly, I want to show you on your AP Biology equations and formula sheet. This will be added to Google Classroom as one of your year-long documents you can use at your leisure. Here is standard deviation right here at the top. This S stands for standard deviation. We're taking a sample mean. Okay, our values here are going to be for that sample mean, and then your values for however many were in your sample. Your sample size, you're going to square root that, and you're going to get your standard deviation. And that's exactly what our Google Sheet has calculated for us here. Now, come back. I'm not going to interpret this for you. What this value means, big or small. You're going to spend some time looking at those resources that I posted for you and determining what these standard deviation values mean for your additive types. Now, what I'm going to do though, I'm going to use the same trick. I'm going to take that formula that's in that cell and I'm going to drag it down to the rest of my additive types. And there we go, our different standard deviations based off of our additive types here, off of their sample sizes. Now let's move over to standard error. Get your fingers nice and limber, maybe crack some knuckles because you're going to be typing in a much longer equation than needs to happen. So standard error again is telling you how your sample mean or how much of your sample mean or how good of a depiction your sample mean is of an actual population mean. Okay, it's kind of extrapolating it. So let's say, for example, there are 1,000 members in the population and you were able to take a sample size of 20 and you calculate a mean from that. How good is that mean as an actual depiction of the actual mean of the population? So if we look back at our equation sheet here, standard error of the mean is a pretty simple equation. Once you've calculated standard deviation, you take that standard deviation over the square root of your sample size, plug and chug, boom, you have standard equation or standard error of the mean. Okay, simple equation. However, when you type the formula into Google Sheets, it's going to be much longer. So I'm going to go slow with this and try to type this in with me while you have your cell open. So we're going to press the equals key with our caps lock on. We're going to type STDEV, little period, S. We're going to put in a parentheses. We're going to select trial 1 through 5. Don't select your mean. Close your parentheses. And this is where we're going to put that over. Okay, so we need our little divide. Our sample. So we're going to go count, C-O-U-N-T. One thing before count, I messed up. See, I'm going a little too fast. I need a parentheses. And then within that, we're going to select our cells again for trial 1 through 5. Close the parentheses, but since I had one at the beginning, I need to do a dual parentheses. You know all about that if you're typing in your scientific calculators. And cross your fingers, press enter. Okay, so there is our standard error of our standard deviation. Let me just double check that formula before I go ahead. It's always good to do because that number looks funky to me. An error in a tutorial? Yes, there is one. Okay, so this is missing something. I forgot to put in square root because we have to do the square root of the sample size, but that's okay. We're going to go back here and we're going to put in the code for square root, which is SQRT, square root. Now I'm going to press enter. Here. And that looks much better to me. Let me just eyeball it one more time. Okay. We have our value. We have our square root of that value, and this is our standard error for that specific sample type. Okay. So now we are going to drag our cursor down, taking that formula for standard error of the mean to the rest of the samples, and there you go. Okay, those numbers look good to me. Again, I'm not interpreting for you what they mean in terms of your additive types, but what we're going to do next is graph. So let me, sorry, my keypad was sticking. I'm going to pause this really quick and adjust. Oh my goodness. Sorry guys, my keypad was not working with me. Pause for just a moment. I'm going to adjust where my window looks just so you have a better field of view here. All right, and we're back. My window looks the same. I'm going to leave it as is. As we graph, we'll move it around. My puppy had to go outside, so bear with me. Okay, so now we're going to graph. We need to select what we need to graph. Our graph is going to be our additive types and our mean. So What you want to do first to get our graph going, you're going to select additive types and drag it down all the way to oil. Now, we want to select two sets of data, okay? So we want to do our axes values and our y. We're graphing our mean here, and then we're going to add our standard deviation in the form of some error bars. Here's a little keystroke that you're going to need to do in order to select both of these sets of data at the same time. You're going to hold down the control key, okay? You're going to click on the first cell of your values for the mean, and you're going to drag it down. Drag it down. Try it again. See, that one didn't work for me. Okay, so we're going to select those. I'm going to hold my control. Oh, my values. Oh, there we go. Okay, try it again. Hold these down. Go over here, hold my control key down, and drag the values down until they are both highlighted. That looks good. So now we're going to go up to this icon here for chart. We're going to click on that. And look at this beautiful graph that's popped up for us. So we have our different additive types and we have our axes labeled here. It looks good. However, this graph is telling us that all of these are the same series type. Well, that's not the case because this is a comparative graph of different samples. So we need to do a little bit of manipulating to this. Okay. So the first thing that we're going to do, we want to change some of our settings here so that we have a different color or a legend that's going to accommodate our different additive types. Okay, they are different data sets. They have different standard deviations that we need to apply. So we're going to go down here. We're going to play around with some of these settings. Let's try if I switch our rows and columns. Yikes, no data. Okay. Now let's say I just want to use, I unselect that. Use column A. Okay, that's getting a little better. I unselect that. Switch our column. Okay. Now we have different colors here. We just want to have our data additive types at the top. So let's say switch, and we're going to use our column A as our header because that's what we want. Beautiful. Now, don't ask me why mean comes up here twice. I can't figure out where that feature is. If you find out, I will be a very happy camper. So now we're to the point where we want to add in our error bars that represent our standard deviation of our trial from our actual mean. Okay, so I'm going to click on my first series or my first data set. I'm going to scroll over. I went over to customize. We're not in setup anymore. I'm going to click on error bars. Okay, these are not a percent. They are an actual constant. So we want to go from percent to constant. And the value that we want is not a value of 10. We want this value here. So we're going to type in our standard deviation that we calculated. It's 1.817. Click that. Make sure constant stays up. All right, there's our error bar for that one. Now, that is a standard deviation from my specific data set and my values. Yours is most likely 100% going to be different, but you're going to type whatever your value calculated from your mean and your trials into this specific spot here for your constant. Okay, I'm just giving you an overall go of it with some sample numbers. Okay, so the next one that we're going to do is the distilled and soap. My mouse pad is not working with me here, folks. You know what? Mine's touchscreen, so we'll just go that way. Okay, so error bars, we want a constant, and then our value for that specific one is 3.962. Okay, I'm going to go over, double check that that worked. Back. Okay, that one's good. Let's go to our yellow. Go here. Oh my goodness. Click on this data. Sure, fine. Go back to customize. Okay, so I want this one. Okay. And I'm going to go down to error bars. click on constant, put my value in, 2.074. Okay, put our error bar back there. That's a little one. Okay, that might be significant. You can see the different sizes here based off of that data. Back to customize. I don't know why it won't let me select off of the bars. It's a Google thing. I'm sorry. If it doesn't let you select it, you go back up to your series here, your drop down, and you select it there. Okay, we want our error bar. We don't want a percent, we want a constant. We don't want a value of 10, we want a value of 2.074. Funny enough, they have the same standard deviation. Okay, and there is our graph with our error bars that you can then interpret. The last thing I want you to do is to put a little flavor into your title here, make it a little more elaborate than just your X versus your Y. They should be there, but you could give it a little more description in terms of what those two variables are. Okay, so I hope that that helped you guys set that up. This is just a tutorial to kind of walk you through how to set up a graph in Google Sheets. What are the parts that a graph should have in Google Sheets in order to be considered a perfect 4-point graph for AP? Because if you don't have all the points, you get 0. I know, that's pretty harsh. And then also how to use standard deviation calculation as well as standard error. Okay, I know that was a long one, but I hope that this helps and you guys are able to pause it and go back as needed to get you through that graphing process.